we are told calculate the Gibbs free energy for the reaction. So we've got a reaction there, and then they want us to calculate the Gibbs free energy. Okay, so don't worry, with time, as you get more familiar with this topic, you'll be able to understand what the symbol stands for. That's Gibbs free energy. That part there indicates standard Gibbs free energy. And then there's also what we call standard cell potential, which will be like that. Okay, so one of the first things that you calculate under electrochemistry, you calculate what we call the standard cell potential. Okay, call it the E cell. So Gibbs free energy is dependent on the negative and Faraday's constant and then the standard cell potential, implying that before you can determine the Gibbs free energy, which determines whether a reaction is spontaneous, and of course by the reaction being spontaneous, we actually imply that it's favoring the product. Okay, so when it's negative, when the answer is negative for a standard for a Gibbs free energy, when it's negative, it's spontaneous. If it's positive, it's not. Well, it's the opposite for the E cell. If it's positive, then the reaction is spontaneous. So let's try to see what will happen here. So let's look at the reaction itself. Let me take you back to the reaction itself. The reaction was between copper 2 plus, I'm just copying that equation, and then plus the ion, giving us the copper solid plus the iron 2 ions. Okay, that's our reaction. Now let's try to observe the F reactions and see if they are actually written properly. So they are both written in a reduction form, so we have to see which one will become the anode there. So if we try to observe, just counter check against, copper 2 plus is on the left, so that's actually okay. Now if you check ion 2, they're on the opposite side, so we have to reverse that F reaction. So we'll start with that instead. So ion solid gives us the ion 2 plus ions aqueous plus the 2 electrons. Okay, so the moment you just do that, this value changes the sign when you reverse. So since it was negative there, it's going to become positive 0.44 after reversing. There are also cases where you find that the number of electrons are not balanced. In that case, you are required to balance up, just the way we used to balance a simultaneous equation. So you multiply this one by 2 throughout, but then that value is not affected by the introduction of multiplication. So at this point, things have become easy now. When you know which one is oxidation and which one is the reduction reaction. So this one is the cathode, and then this other one is on the anode where oxidation occurs in a galvanic cell. So therefore, when it comes to the calculation of the E cell, when you've reversed and you've changed the signs, just add the values. So the values therefore are going to be 0.34 volts on top plus 0.44 volts on the bottom. So that gives you a 0.78 volts. Other people would maintain everything as it is and just identify the anode and the cathode without changing the sign, and then they just say we're going to subtract the cathode by the anode. So 0.34 minus negative 0.44, which of course will just end up to 0.78. Okay, so calculating our Gibbs free energy therefore becomes substitute N represents the number of electrons, so you've got a minus 2 multiplied by the Faraday's constant, which will be given in your exams, and 6485, and 0.78, which is our standard cell potential. And so all you have to do is just grab the calculator there and punch the values. So the units for the Faraday's constant, coulombs per mole. Okay, So what will happen here is we're going to have a value of negative 150,729 joules per mole. Okay, which if you want you can divide by 1,000, so it just becomes negative 150 0.7, okay, kilojoules per mole. So these are the units for the standard free energy. Take note of it. So it's energy, so joules makes sense. Of course, the mole coming from the equation itself. So this is our answer. Now, is it negative or positive? It's negative. So would you say it's spontaneous or not? So the reaction was spontaneous, implying it was favoring the forward reaction or the product formation. Okay, so question 2. For the oxidation reduction reaction, the appropriate half reactions are these given right there. Balance a redox reaction, calculate the standard cell potential and K at 25 degrees. Okay, so this is an example I was actually giving you right on top there, if you remember. Okay, so I want you to pause the video and attempt to balance first of all the equation, and after you've done that, I'll give you the let me actually give you the formula straight away. So the formula, there's a formula to raise a standard Gibbs free energy to the RT natural log of K, the gas rate constant natural log of K. Of course, this equation comes from the calculation of the non-standard Gibbs free energy, which is the summation of that. Okay, but then in a case where this is equal to 0, that's where that formula comes about. In fact, there's a negative there. Okay, so that equation is going to be useful to help us calculate the value of K by substituting in that, which we can calculate. These ones are given, the temperature and the gas rate constant 8.3145, and then yeah. So I want you to pause the video and try that question out.